All right, in this lesson, we're going to look at dividing polynomials. What does that mean? And to start off with, we're going to get back into long division. So it's maybe been a long time since you've done some long division. It's not something we use regularly, but it actually comes back and is very useful for polynomials. But let's just remind ourselves how to do long division. So if we want to do 77 divided by 2, let's write down 77. We have the long division kind of symbol like that, the division symbol, and the 2 on the outside. And what you do is you take this 2 and you just work with, let's say, the first part, the tens column in a sense. How many times does 2 go into 7? Or what is 7 divided by 2? And we're just rounding things off. So you always go with the smaller things. So in this case, 3 instead of 3.5. Because what we're going to do is we're going to figure out what that final, we call it remainder, is what's left over when we divide through this long division. Okay, so that's the first step, do that division. The next step is, so let's write that, divide. Then we're going to multiply things back through. So that number we just divided, we got an answer of 3. That's the whole number, because of course it'd be 3.5, but we take that whole number and multiply it now back into 2. And that answer we're going to write below. Because what we're doing essentially is we're going to find out, well, if we took the answer as 3, what is actually left over from that division? And so the last step then is, well, what's left over? And that's going to be our subtraction step. Divide, multiply, and then subtract. And well, what's left over is, well, 7 minus 6 is 1. And then bring down the 7, the other one, we get 17. Okay, and now we want to figure out, well, what is 2 into, we can't divide it into the 1 anymore, but we can divide it now into the larger thing, which is 17. So we basically now repeat the whole process. So 2 into 17 is going to be 8. So that's the multiplication step. Write that down up above, and then multiply that back in. Or sorry, that was the division step. Multiply that back in. 8 times 2 is 16. And then 17 minus 16, the subtraction step, gives you 1. 2 can no longer divide into 1, so this is the remainder. So 77 divided by 2 is 38 with a remainder of 1. And we can look at this kind of as like we can call it a multiplication statement. So I could say 77 is equal to the dividend, which is 2, times the quotient, 38, plus 1, the remainder. So yeah, that's the terminology there. Quotient, dividend, and remainder. Okay, let's practice that with a little bit of a bigger situation. So 1724 divided by 13. So we'll write 1724. 13 out in front. So we take this 13. Can't divide it into the 1, but we can do it into the 17 there. So let's just do that to the side. 17 over 13. Well, 1 is the biggest thing that can, or one set of 13 is the biggest thing that you can fit into 17. So we write a 1 there. Now multiply that back through, and we just want to see, well, what is left over? Well, what's left over is just going to be 4. And then we can drop down the next number, 40, to make 42. And just repeat the process. So it's an algorithm. It keeps repeating over and over again. So once you get the hang of this dividing, multiplying it back through, and then subtracting, once you get the hang of that, then long division will will get much better for you. But it's just getting that process down. Okay, so how many times does 13 fit into 42? We have 13, 26, 39. So it'll fit in 3 times at most. So now I write down the 3 up there, and again multiply that 3 back into 13, see how much is left over, and we'll see that 3 times 13 is 39. And so subtract to figure out, well, what is left over? Well, 39 take away, well, 42 take away 39 will be 3, and then drop down the next number to make that 34. And then again, just keep repeating. So 34 over 3, what is that? Well, that is, at most you can fit, I should write that as 13. As most you can fit it in 2 times the 13 into 34. Write that at the end there, multiply it back through. 2 times 13 is 26, so write that at the bottom. Subtract, you get 8. 13 can fit into 8. There's nothing else to drop down, so that is our remainder. So I could actually say that, well, 13 times 132 plus that number 8 is equal to 1724. Or 1724 divided by 13 divided by 13 is just equal to 132 plus 8/13. That's another way of looking at that. It's essentially the decimal, the fraction at the end. Okay, so now let's move on to the world of polynomials. How is this going to work out with polynomials? Well, the algorithm is going to look the same. We just need to think now in terms of variables and polynomials instead of just numbers. So we're going to divide 2x squared plus 7x plus 3 by x plus 3. So the x plus 3 is going to go on the outside. The 2x squared plus 7x plus 3 is going to go on the inside. And just like we did with the numbers, we're going to be kind of going piece by piece. And as we go piece by piece, what we're doing is we're going to just divide by the biggest thing there, the x plus 3 in this case, just the x. So that's where it's maybe a little bit different looking. So I'm just going to do 2x squared divided by x. And what is that? Well, it's just regular division. So x squared will cancel with an x and leave you with a 2x. And so I'm just going to write that above the term with an x already, just to kind of line things up, keep things with the same exponents, vertically aligned. Okay, so that is the division step. Okay, next, in our algorithm up above, we said multiply. So how's that going to look like in this case? We'll take the 2x, multiply it by the entirety of x plus 3, and write it below. So 2x times x plus 3 is just 2x squared, plus, and well, 2x times 3 is going to be 6x. And now we're basically going to see what is left over. So that's the subtraction step. And if you subtract, what will always happen with long division, especially with polynomials, is the first term should always cancel out. What we'll see is we'll have some left over with a lower degree term. So in this case, it'll be 7x minus 6x. We'll leave you with just an x. And we'll move down the 3 like that. But yeah, that thing you get left over is always a degree less than what you started with, or it could even be lower than that, but it should always lower the exponents. So eventually you'll get to something that essentially can't be divided by x plus 3 anymore. Okay, so now repeat the process. So now we have this x plus 3. We're looking at that, but we're just looking at the starting part, in this case the x, and divide it by x. So we'll call that 1. We'll call this, or we'll call this a. Now b will be x divided by x, which will just be 1. And so then that's what's going to go next. So 2x plus 1 and multiply it back in. And you'll see 1 times x plus 3 will just give you x plus 3. And then subtract. And if you subtract, you are left with, well, 0. So you actually have nothing left. You have no remainder. So that's the remainder there. So what we can say is 2x squared plus 7x plus 3, when you divide it by x plus 3, you just get 2x plus 1. Or another way I like to look at it is the multiplication statement, which is where you just multiply the two things, your quotient, your answer, with what you were dividing by. And if you had a remainder, you would add on the remainder is equal to that original polynomial. And what you can see is, well, let's get rid of that remainder. What we just done, 2x plus 1 times x plus 3, that is actually just that polynomial factored. So what we're going to see is division is a way we can help ourselves to factor. Okay, let's continue though, just getting used to long division. We're going to skip that and we're going to just go through some of these examples together. Okay, so let's go through these divisions. So we're going to look at a bigger division, but the process is going to be the same. So we're going to look at 2x cubed minus 9x squared minus 10x plus 24 divided by x minus 2. And again, it's just going to go in order. So we're going to start with 2x cubed. Divide that by the lead part here, the x, and that's just going to be 2x squared. So that's going to write it vertically above the x squared part, like that. Multiply that through, and we get 2x cubed, and 2 times 2 is 4, minus 4x squared. Just be careful of the double negatives. That's going to happen when we subtract. So the first part will cancel, the 2x cubes. Negative 9 plus 4x squared will leave negative 5x squared. Okay, and I'm just going to bring down the minus 10x and repeat the process. So we have the minus 5x squared. We're going to do that to the side, divided by the x. That's going to lead us to negative 5x. And so I'm going to write that here above the 10x. Okay, multiply that back through. What is minus 5x times x minus 2? Well, negative 5x squared. Again, that's matching. It always will. And then negative 5 times negative 2 is 10x. And we can subtract. And if we subtract, first part cancels. Negative 10 minus 10 is negative 20x. Bring down the 24. We can still keep dividing. Divide by that part in front. So negative 20x divided by x is just negative 20. So we have a minus 20 here. And if you multiply the minus 20 back in, you will get minus 20x. 2 times 20 will be 40. Subtract. And what do we get? First part cancels out. 24 minus 40 is a negative 16. And x can't divide into negative 16, so that's where we stop. There's nothing else to bring down. Okay, so that's a look at that example. So what does that mean for our answer? Well, one way we could write this answer, I like to write it as a multiplication statement, is you could write it as x minus 2 times what we just got, 2x squared minus 5x minus 20. We have a remainder now, so that minus 16 would give you the original polynomial, so 2x cubed minus 9x squared. I'm just writing it below because I didn't give myself space, minus 10x plus 24. So there we have it. Okay, let's continue. So x minus 4 divided by that. 3x cubed minus 11x squared minus 16. What you'll notice is we don't have an x term here. So if you're ever missing a term like a power of x in your sequence of x's, what actually is very helpful is to still include it, So I'll do this in different color, 0x. Because it just helps you to keep your algorithm structured. Because sometimes if you don't have it there, you end up missing some parts of your algorithm work. Okay, so now, as you're going through this, you can, of course, try these out yourself. I always encourage that. Try all the examples yourself first, and then get your answer afterwards. Watch the video afterwards. Okay, 3x cubed divided by x is just 3x squared. So write that up above the x squared portion. Multiply that back in. So 3x squared times x minus 4 is just 3x cubed minus, well, 3 times 4 is 12. And now subtract. So subtracting that, you will get 3's cancel. Negative 11 plus 12 is x squared. Drop down the 0x. Feels weird, but again, just helps us keep things organized. And you'll see why in this next step, why that will help. Okay, so we have the x squared in front. So x squared divided by x is just, well, just x. So we get plus x there, multiply it back in. And so if we multiply it back in, you get x squared minus 4x. And so then we subtract. So the x squared cancels, and this is where having that 0x is going to help. Because then now we can see, well, we have a 0x subtract, well, negative 4x will lead to a 4x here. Sometimes if you don't include that there, you might miss the x term as you go through the long division process. Bring down the 16 and repeat one more time. So 4x divided by x is just 4. So we'll add plus 4 and just multiply that back through. So 4x times 4 times 4 is 16. And that gives you 0. We've got 0. We're done the division process. And what this tells us is x minus 4 times 3x squared plus x plus 4 is equal to that original polynomial, 3x cubed minus 11x squared minus 16. Again, what we've just done is we've actually just done a little bit of factoring. We've turned the original polynomial into something that's multiplied with brackets. That's what factoring is all about. And we'll see how we can get better at that in future lessons. Okay, 6x squared minus x 15 divided by 2x plus 3. Okay, so now we'll see what's happening a little bit different with this example. Let's just write down the statement. So again, we're always starting with what's in front and dividing the two. What's different though is now in each of the previous examples, you'll see we are always dividing by x. It doesn't always have to be x though. So in this one, we have a 2x. So divide by 2x. 6 divided by 2 is just 3. X squared over x is x. So you just get 3x there. But the rest of the process remains the same. 3x multiplied into 2x plus 3. That's going to be 6x squared. And 3 times 3 is 9. And so if we subtract that, 6x squareds cancel. Negative x minus 9 is going to be negative 10x. Bring down the 15. And then repeat. What's in front? Well, we have a negative 10x in front, so let's just write that down to the side. Divide that by 2x. Negative 10 divided by 2 is a negative 5, and the x's disappear, so it's just minus 5 like that. So we have 3x minus 5. Let's multiply the minus 5 through. So negative 5 times 10, or negative 5 times 2 is 10. X, negative 5 times 3 is 15. Again, they cancel when you subtract. you get no remainder. What this means is, I'll write this out in a little bit of a different way. When you divide, because that's really what we're doing there, 2x plus 3, you just get 3x minus 5. If you multiply the 2x plus 3 back over to the right, that's where you get that multiplication statement. Or what you're actually getting is the factored form. 3x minus 5 times 2x plus 3 is 6x squared minus x minus 15. All right, let's continue just to see more variety of examples. But again, you can see this process is repeating. You're always dividing, you're then multiplying through, and then subtracting to see what's left over. Repeat that over and over again. We just want to see what different situations might arise. All right, let's do this one. 2x plus 1 divided by 6x cubed plus 7x squared minus 8x minus 5. Okay, so what do we want to do? Take that lead coefficient, or lead term, divide it by the lead term that you're dividing by. So 2x is dividing into 6x cubed. That's going to leave you with 3x squared. So I'm going to write that above the x squared column. Multiply that through. 3x squared times 2x plus 1 is 6x cubed plus 3x squared. And subtract. First part cancels. 7 minus 3 is going to be 4x squared. Bring down the 8x. And repeat. So 4x squared divided by 2x is going to leave you with 4 divided by 2 is 2, and then an x. Multiply that back through, and when you multiply it back through, you will see you get 2 times 2 is 4x, 2x plus 1, 4x squared, I should say, and then 2 times 1 is 2, and then x. And subtract. So then you have the first part canceling. Negative 8 minus 2 is going to be negative 10. And bring down the minus 5. All right, and repeat. So now we have negative 10 in front. Divide that by 2x. That's going to be negative 5. So minus 5 there. And multiply that minus 5 in. So it's minus 10. Negative 5 times 1 is a negative 5. That gives you 0. So what have we seen? Well, we've seen that 2x plus 1 times 3x squared plus 2x minus 5. That is actually that big polynomial, 6x cubed plus 7x squared minus 8x minus 5. Okay, I don't need that last bracket there. All right, so again, we're breaking down that big polynomial into smaller polynomials, essentially. Again, kind of the key to factoring. All right, x cubed plus 2x minus 7 divided by x plus 4. So again, try these out on your own, but I'll just go through the process here. But don't hesitate to try it yourself. Okay, so we have x plus 4, x cubed. Again, we're missing a power of x. So I'm going to just kind of put a placeholder in, and that will just help us to keep things organized. So we'll start with x cubed and x, and that will give us x squared. And multiplying that back through is x cubed plus 4x squared. Okay, and subtracting, we will get negative 4x squared. Okay, and I'm going to bring down that 2x. And now repeat the process. So negative 4x squared divided by x. That is going to be negative 4x. Multiply that negative 4x by x plus 4, and you get negative 4x squared. 4 times 4 is 16. And I'm just going to put the minus sign in front. Careful about your double negatives, so 2 plus 16 is 18x. Bring down the 7, 18x minus 7. All right, and with that 18x there, the 18x, that's divided by x now. And so that's just going to leave us with 18, which is what goes up atop of that. Multiply that 18 by x plus 4, so 18x. 18 times 4 is 72. So subtract that. 18 is cancel out. Negative 7 minus 72 is negative 79. And that's okay. We can't have a remainder. I know we had a lot of zero remainders there, but remainders can happen. And so we can write down the fact that x cubed plus 2x minus 7, that is just equal to our dividend, x plus 4, our quotient, x squared minus 4x plus 18, plus the remainder, in this case, negative 79. And there we go. That is that divided. Okay. Let's look at one last example. 6x squared plus 4x minus 2 divided by 2x plus 1. Again, try it out yourself. And then go through this. Okay, so this is one where you have a lead coefficient, 2x. But again, the process is still the same. Divide now by 2x. Okay, in this case, that's 3x. And multiply it through. And you'll get 6x squared, in this case, plus 3x. Subtract, the first part cancels. 4 minus 3 is just 1. And bring down the minus 2. All right, then you have the x there, so we're going to have x divided by 2x. Okay, this one's not as nice, but this can happen. So the x's cancel out. You're just left with a half. We haven't had fractions yet, but fractions do occur, so just be aware of that. So I'm just going to write it as a half there, and we multiply the half in, and you'll get 1 half times 2 is just x. 1 half times 1 is just a half. And we're subtracting that, and you're left with, well, the x's cancel out. Negative 2 minus a half is negative 5 halves. And so, yeah, just be careful. Fractions do happen. So we can say 6x squared plus 4x minus 2 is equal to 2x plus 1 times 3x plus a half minus 5 over 2. And there we go. So again, just in terms of what we have here, we have the dividend, the quotient. Oh, sorry, I should correct this. Not dividend. Dividend is actually this thing. This is the dividend. I'm just confusing my terminology. The thing we're dividing by, that's the divisor. Just be careful about that. Easy to confuse the two. So yeah, the divisor, the thing we're dividing by. So the order still stays the same. Divisor multiplied by the quotient, that's the answer of your division statement. And your remainder. So that's how we get that statement there. All right, and there we have it. That is some long division of polynomials.